Now, the last thing that's left is for me to talk about the left side of this picture. The left side of this picture actually defines my entire system in the types of system. So I can now talk about the things that I was talking about in chapter 3, which is closed, isolated versus open systems. And how does statistical mechanics define those kinds of situations? So let's talk about those now. So I'm going to do 12.3, which is statistical description of the macrostate. So what do we know? We know that in statistical mechanics, we use an ensemble to represent the possible states of a mechanical system. Now, suppose we have an isolated system with a fixed number of particles n that are identical and weakly interacting, and they are contained in volume V, and they have a fixed energy, internal energy, E. So what are the steps that I need to define in order to define the macrostate of this system? Okay, so steps to follow. To define the statistical macrostate. Number one, solve problems that have only one particle. Number two, count or list all possible distributions. Number three, count the microstates corresponding to each distribution. And number four, find the average distribution. So those are essentially the 4 steps we need to follow. Okay. After this, we have to define these steps to real thermodynamical systems. So if we are talking about real thermodynamical systems, we have to talk about 2 main things that we did before: solids and fluids. So I'm going to define my thermodynamical systems as either solid ensembles or fluid ensembles. So all my thermodynamical systems will now be divided into solid ensembles or fluid ensemble. So in a solid ensemble, say of n particles, we can distinguish the particles between themselves, not by the fact that the particles themselves are different, but we can do a spatial recognition on it. So we know the XYZ of each particle and their location because they can't move. And that is how we know that each particles are distinct by the lattice sites. So we distinguish these particles by the virtue of lattice sites. For fluids of n particles, we cannot distinguish them. Why? Because they're constantly moving around, right? And they're interacting with each other, they're hitting each other, colliding with each other. So it's very hard to figure out what the fluid ensembles are doing. Like if a gas molecule, just 1 mole of gas will have enough particles that you can't keep track of it. So how do we simplify the system? Well, we simplify the system by generalizing our thermodynamical ensembles into 3 categories. We will define them for a system that is bound by a volume V that has a number of particles N and has internal energy E, with a very simple explanation.